Assalamu alaikum. So in our previous class, we were discussing about laser, and today we will be starting the new topic, refraction of light. Refraction of light. So even during your OLs, you might have studied about refraction of light. When light moves from one medium, when it is moving from a certain medium to another medium, then let's say this is water. If light moves from air to water, what happens is it will bend. So this is a light ray. Without deviation, it would have gone like this. But when it is entering water, which is a dense medium, it is bending towards the normal. Okay, we call this one as the normal. Now this is our surface. This is our surface. And this is the normal to the surface. Normal means perpendicular. Normal. So the angle emerging incident light ray makes with normal, we call it as the incident angle. And the angle the refracted light ray makes with the normal, we call as the refracted angle, R. When light travels from rare medium to dense medium, it will bend towards normal. And it is the opposite when it travels from dense to rare. So let's take an example. This is a block of glass. The light is traveling from glass to air. So without any refraction, it should have gone like this. But due to refraction, it bends away from the normal. So now this is the refracted angle R, and this is the incident angle I. So here, this is glass, and air. So the glass is the dense medium and air is the rare medium. So this is dense and this is rare. And this phenomenon of light ray bending, we call it as refraction. Okay. Draw these two diagrams quick. Normal means, now this is the surface. This is the incident surface. If you draw a perpendicular to that incident surface, we call it as the normal. So when light ray is traveling from rare to dense, it is traveling from rare to dense towards normal, and dense to rare, away from normal. Are you all clear with the idea? Shaira, how about you? Is the screen clear? My font size, is it fine? the deviation of okay, so there's a problem, right? You cannot see my cursor. Um, yeah, I get it. Okay, I'll try to do something with that. Okay. I don't know why it's not showing the cursor. Mm, now is the cursor visible? If I use this, will it be clear? If I use this to underline what I explained. When I write on the screen, is the cursor clear? Sorry, is the cursor visible when I write? But you all can see, right, when I'm writing, the place where I write. Okay, so here, normal means this is our surface, okay? This is the incident surface. If I draw a perpendicular to this incident surface, that is the normal. Okay, Najima, did you get it? What is the normal? The deviation or change in the path in the path of light ray of light ray when moving from or when passing from one transparent medium to another is referred to as refraction of light. Refraction of light. So let's write a note below it. Note number one. What is the reason? Why does it have to change path or deviate or bend? The reason is, as we discussed previously, what can you tell about the speed? Speed of light ray in air and in a medium. Are they same or different? Obviously, they are different. In a medium, it is less than in air. We have discussed this. So, in different mediums, we have different speeds. Depending on the speed, it bends. Okay, depending on the speed, it bends. The medium in which speed of light is slower slower than in the other than in the other is a optically dense medium is a optically dense medium. So here, when we are talking about dense and rare medium, we are not using the density that we talk about. The usual density we talk, kilogram per meter cube. We are not talking about that density. This density, we call it as the optical dense, optically dense. That means here we have a different measurement. Okay. Second, when light ray is incident at 90 degrees, when light ray is incident at 90 degrees, so this is the surface, and we have a light ray that is incident at 90 degree. When it is incident at 90 degree, then there won't be any refraction. So this point is very important. When the light ray is incident along the normal the light does not undergo refraction. Yes, Shaira. If the speed is less, it means it is dense. Okay. So, Imla, you're asking why, right? Have you studied about wave front? Have you started waves? Okay. So once you complete wave front, let me know. I will explain because we need the idea of wave front to understand why refraction occurs and why it does not undergo refraction when it goes at 90 degrees. Okay, I'll tell a simple example. If you look the waves in the sea from top, it will look like this, right? Agree. If you look the waves in the sea from top, it will look something like this. So these things on top here, when you connect all the crests together, when you connect all these crests together, this is how it will look from above. Okay. If it was a straight wave, I mean, the wave is not having any bends in it, you will see like straight lines. Okay. Now, can you remember we discussed when light travels from one medium to another, light is traveling from this medium to the next medium. What about frequency? Will it change or remain the same? Will the frequency change or remain the same? I mentioned that frequency will remain the same, right? It doesn't change. If frequency doesn't change, how can speed change? So we know that speed is f lambda. If frequency is constant, then the only way velocity can reduce or increase is by changing its wavelength. The wavelength has to change. It has to either increase or decrease. Now, when the uh, light is incident at 90 degree, so light is also waves, right? So this is the wave, okay? In light ray, we have electromagnetic wave. And which one is the ray? If we draw a straight line through the middle, that is what we represent as ray. So this is the wave and this is the ray. When we are dealing with geometry, which one is easy for us? Rays is easy. To show refraction, reflection, diffraction, and everything, ray is easy. Now, I'll talk about waves here. Now we are talking about waves here. So, the ray will look something like this when I show it from the top. Agree with me? If I show the top wave, this is the ray. Did you all get it? This is the ray. And let's say we have a dense medium here. We have a dense medium. So what should happen to the speed? It has to decrease. Just by getting closer, just by the waves getting closer, what can happen to the speed? The speed can reduce. Okay, the speed can reduce. So when it is at incident at 90 degree, when the light ray is incident at 90 degree, the speed can reduce. Shaira, did you get this idea? This is wave, and what we draw through the center is the ray. Are you clear with that? How about Najima? Are you clear with that? This is a wave and this is a ray. So here, what I have drawn, here I have drawn wave fronts. So in this diagram, if I show you the ray, it will go like this. This is the ray. So everywhere, here also we will have a ray. Okay, here also we will have a ray. So I will draw only one of the ray. So look, if I look from top, these are the wave fronts. These are the wave fronts. And this is the ray. So, Shaira, are you clear up to that? This is the ray and this is the ray and this is the wavefront. Are you okay up to that? Okay, now we want, when light is traveling from this medium to this medium, we want the speed to decrease. So how can the speed decrease? By decreasing the wavelength. So look, if the distance between these two, if the distance between two wavefront decrease, that means lambda decreases, right? So look, here the wavelength is greater, here the wavelength is lesser. So here the speed is high, Here the speed is low. That means the speed has changed. But this light ray is in the same direction. It didn't deviate at all. Did you get that idea? Next, let's look why it deviates at other angles. Up to now, is it clear? Okay, now let's come again to this diagram. In this diagram, what can you tell about the wave front? If you take a single wave front, if you take a single wave front like this, so this wave front, it has to be continuous, right? It has to be continuous. Whether it is curved. Now let's say we can have a curved wavefront. Now look here, over here, I have a curved wavefront, right? Can I have a wavefront like this? You have a wavefront, and suddenly it's discontinuous here and it continues here. Can this happen? Yeah. Okay, I will explain what happens in 90 degrees once again. Before that, uh, tell me, is this possible? Can you have a discontinuous wavefront like this? You might have watched waves at the sea, right? So have you seen any wave like this? No, it cannot. Okay, it cannot. It has to be continuous. So let's look what will happen if a ray is incident at a certain angle. Now this ray is incident like this. So here you have larger wavelength. Okay, you have a larger wavelength. When getting into this medium, let's say it is refracting. If it is not refracting, so this is the wavelength, and this is the wave fronts from top. Now tell me, can we get waves like this? Can we get wave fronts like this when going from this medium to the other medium? Is this wave possible? According to this diagram, tell me, is this possible? No. Why? The reason, are we getting continuous wave front? No, we are not getting continuous wave front, right? Najima, are you clear? If it is like this, we are not getting continuous wave front. Now let's see. I want a condition. I want lambda to decrease. What if the lambda is like this? What if the rays go like this? What can you tell about the wavelength? Wavelength, has it decreased? In between these two diagrams, has the wavelength decreased? Yes, it has decreased. What can you tell about the wavefront? Is it continuous? Yes, it is continuous. Wavefront here is continuous, right? So wavefront is continuous. And I'll draw the ray. So if I draw the ray, I'll draw the ray. So it comes like this. It has bent. Okay. So Najima, look at this. Look over here. Because I have only drawn two continuous waves. It is continuous, right? And forget about these two rays. So this wavefront is continuous, right? If I draw one more over here, you will get the idea. Yes or no? Shaira, how about you? Did you get the idea? Okay. Shaira, are you clear? Here it's continuous. we are getting a continuous ray, a continuous wavefront. Are you clear with that? Okay. So how to know that wavelength has decreased? Now, this is the wavefront. Okay, this is the wavefront over here, and the distance between two wavefront will give you lambda. That means distance separation between two wavefront is lambda by 2. So if the separation between two wavefronts decrease, that means lambda has decreased. If separation between two wavefront increase, that means lambda has increased. Shaira, clear? So that's the reason for refraction. Okay. So the reason for refraction, that is not in our syllabus, but if you understood, you know why it is happening. And I thought it would be hard to explain, but it isn't that hard, right? Now you should get the idea why it won't refract at 90 degree, why there is no refraction at 90 degree. Here already lambda is decreasing as well as the wave is continuous. When it is moving at 90 degree, you don't need to have, continuous waves, right? You don't have continuous wavefronts like this. So it's automatically decreasing in wavelength. Okay. So is everyone clear with the total reason why refraction occurs and why there is no refraction at 90 degree? Was it hard? Okay, so when light ray is incident along the normal, the light ray does not undergo refraction. That's note number 2. And note number 3, now we have a light ray that is incident at theta 1 and refracted at theta 2. If the light ray is incident from medium 1 to medium 2, if it is incident at theta 1 degree and it refracts at theta 2 degree, it will be the same if I incident at theta 2 degree in the second medium. It will leave the first medium at theta 1 degree. The second note, when light ray is incident along the normal, the light does not undergo refraction. Okay, Shaira. So at 90 degree, it won't bend. It will just move straight. There is no refraction. So here, note number 3, light is reversible. Light is reversible. So this is medium 1. medium 1 and medium 2. Again, it's the same medium 1 and medium 2. So in medium 1, when you incident at theta 1, it leaves with theta 2. And in medium 2, if you incident with theta 2, it leaves with theta 1. Okay, Najma, just think like this. Now we have a glass block. Let's say when you incident light at 30 degree, when you incident light at 30 degree, its refractive angle is 25 degree. Okay. And what you do next is you do the reverse. You incident at 25 degree from the glass. Okay, you incident at 25 degree from the glass. So what can you tell about the angle it leaves? What is this angle? This angle will be 30. It is just reversed in direction. Did you get the idea? Have you noted? Okay, Shaira and Najima. So we can discuss some. Oh, before discussing some example, we have a theory, Snell's law. Once we discuss that, we can do some questions on it. The meeting will end now. Use the same link to join.